Good morning to all. I am DBMS, Assistant Professor of Department of Computer Engineering in S.A.E. Engineering College, Poonamalli. Today we are going to discuss about the topic is mapping ER model into relational model. Before going to see about ER model detailedly, first we need to know what is mean by ER model, then what is the use of ER diagram in this DBMS, then how the symbols are used to represent the ER model, then later on how the mapping has been taken place from ER model into relation model. At last we are going to see about the gate questions. Okay, then first we are going to see about what is mean by ER model. It is a simple and understandable model for representing the structure and logic database. So it doesn't know how the back in the database has been stored. Okay, so it shows it is a diagrammatical representation of the database. Then entity relationship diagram explains the relationship among the entities present in the database. Okay, so it is a ER means entity relationship. The diagram, it shows how the entities are relating between in the database. Then what is mean by entity? Entity means it's a real world objects relation between the real world objects. For example, you can say the person, car, bike. So what are things we are seeing in a real world, everything will be treating as an object. We may call it as also entities. Then next, it is a structural format of the database. The next, why the use of ER models in database? So in this PPT we are going to see about what is ER model in database. It means it is already I told you that it is a diagrammatic representation. With the help of symbols we can able to draw the ER diagram, and one more the main thing is we are with the diagrammatical representation we can able to reduce the table size of the database. Then it gives a standard solution for the visualizing the data logically. So with the visualization itself we can able to summarize the content in a very short format. And then last one thing, for developing the ER model we no need to know about the hardware or software developer. So we came to know the only the symbols of the ER diagram. With the help of that we can able to draw it very easily. That's a statement here given. Very easy to understand and easy to create, even for native user also they can able to create a ER diagram. The next, what are the symbols used in ER models? So here the figures names are given, the symbols, what the representation takes place in this column they given. So for example, I am going to take one relationship, that is if the student and college okay, so now I am going to draw one ER diagram. With the help of that we can able to understand the symbols what is present here. Okay, so now I am going to take student, it is an entity, then another one is college. Okay, so the entities are represented in the form of rectangular shape. The student may have the student ID and also student name and their address. These are represented in the form of ellipse, oval shape. What it means the ellipse, it represents the properties of the entity, because the student here the entity what are the properties of the student? We takes student ID, name, address, and then date of birth and also the contact number. Okay, the student entity may contain these kind of attributes. Then we are going for college. This is also one kind of entity which has been represented in the form of rectangular shape as we are seeing here. Then college may have the college ID, name of the college, and address, and also the departments. Okay, so here the student and college we are representing the form of rectangular. Then these are the attributes of the student and these are the attributes of the college. Then how the connections takes place between the student and the colleges with the help of the diamond symbol. It means the relation between the two entities. Okay, it means studying. Okay, so the next one is line. It is interconnecting between the entity into the relational. Meanwhile, here also the same thing, the college is an entity, this has been connected into the student relation. The next, double line. So what it means multi-valued attribute. See, multi-valued attribute means if the student may have the may have one or two mobile numbers. So the person can have the two numbers that has been defined as a multi-valued attribute. If the attributes have more than one value, that has been treated as multi-valued attribute. The next one is double rectangular. It means weak entity. It means the entity should depend with another entity. It cannot act as a normal. The next, if any other entity is defined with an underlined symbol, this will be treating as a primary key. Primary key. What it means in this entity, with this attribute alone, we can able to collect all the data. So that will be calling as a primary key. So I think these are symbols which we are using in ER model. Hope you understand about this. Then we are moving to the next slide. Okay. Then next, so far we have seen about what is mean by ER model. ER model means entity relation model. It's a diagrammatical representation. With the diagrammatical representation alone, we can able to understand how the database has been structured and what relation takes place between the two entities. Okay. So far we have seen about ER model and what are symbols are used in ER model. Then what's the need of ER model. Then we are going to see about with the ER model diagrammatic representation how we are making converting into the relation model. Okay, look at the case 1, the binary relationship with one-to-one cardinality with a total participation of an entity. So already I told you the rectangular shape will be as an entity, right? So here person is an entity and passport is one kind of entity. So the oval symbol always denotes what it means. The oval symbol denotes the attributes of the entity, and what does mean the diamond symbol denotes? It is a relationship between the two entities. Okay, they might have a number of attributes. We don't want to mind that. First, you have to consider what are the things which has been present in this page. Here, person ID has been declared. It has been mentioned as underline. So already I told you that if the attribute has been declared with an oval shape with the underline symbol, that will be treating as a primary. That will be as your primary key. It means what? If with the help of the key alone, we can able to identify the attributes which are present in the single person key. Okay. So now what we are going to do is with this ER diagram, we are going to convert into the relational data model. Relational data model is nothing but it is a table format. That's it. How the database has been stored in the back in the database. So now we are going to see about the entity of the person P1. So person entity relation model. So what it contains? It contains person, ID and then other attributes. Might be name, address, contact number, father name, mother name, whatever it is. But mainly we are focusing about the primary key in this topic. The next, what is another entity here? The passport. Now we are going to draw the relation model. It means a table format. Okay. So the passport entity must have the passport number and then other attributes. Then one more thing is here. It means what? The dimensionables already told you this relationship. We have to draw the other table for the relationship also. It has the primary key of the both because it has the relationship between one-to-one between the person and passport. It contains one-to-one relationship, so it must have the primary key of these two, that is person ID and one more thing is passport number. So this table must contain these two things, person ID and other one is pass number. Okay, so all person Every person don't have the passport. The person may have zero or may not have zero, may have passport or not, but anyhow the passport number owned only by the one person. It means one passport number denotes only the one person. Okay, so what I am going to do with this, there is a ER model, now it has been transferred into the relation model. Okay, now what I am going to do is, now I am going to summarize the tables into simplest form. I am going to reduce the tables also. So here look at the table, here I am having person ID and other entities, here the passport number and other entities, hash. This contains these two things. These all are reflecting the same thing. What are the primary keys here? Person ID and passport number. This is more than enough for you. So what I am going to do is, I can able to merge these three tables into one table, that is person ID and passport number. This far enough. Then other attributes. Why should I merge all these three tables into a single table means, because this is a primary key and passport number is a primary key, all are merging with the same thing because one-to-one relation, so that I can able to summarize these three tables into a single table, that is person ID and passport number. Okay, next we are going to see about the scenario case 2, binary relationship with interval. So far we have seen so in previous case what we have seen means one-to-one relationship. So here we are going to see about n-to-1, that is many into one relationship. Here also I am having the same thing, that is student is an entity which has been represented in a rectangular shape. Then it has many attributes, maybe name, address or else contact number, whatever it is. Okay, so here the student ID is in primary key which has been denoted with an underline symbol, the attribute. The other one is this is a diamond shape denotes relationship. What is the relationship takes place between the two entities, that is enrolls. Here the scenarios, every student can enroll only one elective. So every student has to choose any one elective in this elective course. Okay, but for an elective course there can be a more than one student. So in this table now we are going to construct with the help of this scenario. So first I am going to construct the student entity. So student entity must contains the student ID as a primary key, another one is other attributes. The next one is enrolls. What it contains? Already I told you it contains the primary key of these two things, that is S.ID and E.ID. Okay, with the help of scenario only one elective can be chosen. Okay, so here the student 1 has been chosen elective 1. Likewise student 2 chosen elective 3, elective 2. Student 3 has been chosen elective 3, and then elective course. Again I have to draw the table for this elective course. This is a primary key. Elective course may have the n number of electives. With the help of the elective ID we can able to find out the course what it is. Again I am going to draw the table for an elective course. What it contains? Elective ID, then course name. Look at these these three tables, S1, then E1, E2 and E3. Look at these three tables. What are tables I can able to merge and summarize and make them into simpler form? Could you tell? Okay, here the S1 student and its attributes. S1 matches to E1. Here only the E1 alone is here. So we cannot able to merge all three tables into one table. So now we have to merge these two tables into one form. That is student ID, then next elective 1 and then other attribute which is present here. So S2. So likewise, we have to merge the three tables into simpler form. One more thing, many into one table, we can able to summarize into simple form. But one to many, not possible in the table summarization. So hope you understand this scenario. Then we will move to the next topic. Okay, then we will move on to the next slide. Case 3, binary relationship with end-to-end. That is many-to-many relationship. In this scenario, every student can enroll more than one course. One course is compulsory, and compulsory course there can be more than one student. It means what? The student must to register at least more than one course. Then anyhow it has many courses. Course ID may be machine learning, deep learning, then AA. So they must have maybe more than 5 students, 10 students, 15 students, likewise. Anyhow, the student has to enroll at least more than one. That is more than one, or maybe 2 or 3. Okay, in this scenario, again there is a ER diagram which has been given related to the scenario. Thus, already we came to know that as a student is an entity. It has been represented in rectangular form. It has a primary key, the student ID, and there is a relationship between the student and compulsory course. Both two are entities. It connecting the relationship between with the help of the enrolled relationship. It has N to M. That is many to many relationship. Then one more thing, having the compulsory course for customer ID. Again now we are going to draw the table for this scenario. Here student table. Okay. Now the student can choose, student 1 can choosing even. Again the same student can choose the elective 2. Likewise S2 student can choose E2, and S2 student again can choose E4 course, likewise. Okay, so now I am going to draw the table for enroll. So what this table contains means, this table already contains must contains the primary keys of these two entities, that is student ID and course ID. Then student ID means S1, course ID is E1, S2 might be E3, S3 might be E4. Again the student can choose S1 is equal to E2. So again what I am going to do, I am going to draw the relation table for this compulsory course. Again C1 may contains ML, that is E1, already I have denoted as E1. E2 is equal to DL, E3 is equal to might be artificial intelligence. So if you are gone through all these things, we cannot able to merge the tables because all our things are differs. Okay, so even E2, E3, these tables are totally different and these tables are totally different. We cannot able to merge those things in it. So these has been 3 tables. We cannot modify anything. It has been as such. So far we gone through about ER models and what the components are used in ER models. How we can able to make them into the relation tables. Okay, so now theory session gone over. Now we are going to see about the gate questions. So question number 1, let E1, E2 or 2 entities. Okay, so already I told you that E1, E2 are 2 entities which has been denoted in the form of rectangular shape. Okay, 2 entities in ER diagram with a simple single valued attributes. Might be, you may treat it as some X. They do not mention anything. So just a marking as X. It is a single valued attributes. Then R1 and R2 have 2 relationship between E1 and E2. So relation which has been denoted in a rectangular symbol, already we know it well. R1 and R2 between E1 and E2, which has been placed between E1 and E2. The next 1 to where R1 is 1 to many. Okay, so R1 is 1. So wherever you came to know that is 1 to many relationship, for 1 we have to denote with an arrow symbol. So the next one is many. We should not mention the arrow symbols here. It denotes the many relationship. Then R2 is many to many. Here many to many. I think hope you understand the diagram of the scenario. So again I am going to read the question once again. Let E1, E2 are two entities. Here the E1, E2 are two entities in the ER diagram with a simple single valued attributes. Might be no need to declare those things. Did not mention anything. They have some simple value attributes. Then R1, R2 be the two relationship between E1 and E2. It has been placed between E1, E2, R1, R2 are the two relationships. Here the declared as R1 is 1 to many. So that I drawn as R1 1 to many relationship between E1 and E2. And R2 is many to many. Okay, so R2 here are mentioned as many to many. For many to many relationship, we don't want to define the arrow symbol here. Okay, then R2 do not have any attributes, null attributes, okay, of their own. R1, R2 don't have any attributes, okay, null attributes. Then what is the minimum number of tables required here? This situation, what is the relational model? Okay, so already we came to know that for each and every, here we have 4 things, right? E1, E2 and 2 relations R1, R2. So we have 4 tables here, right? Okay, so in this situation, what is the relational model? What is the minimum number of tables required in this situation? Okay, now what I am going to reduce is, so even to, so already I told you many to many, the relation can merge with an entity. Okay, in many to many relationship we can able to merge the relationship with an entity, so that I can able to merge R1 into E2. So this single entity I am declaring as likewise many to 1. Here the many to many, the table has been denoted as R2. So here, so in this question, what is the minimum number of tables required in the situation for the relation model? We have 3. That is E1. E1 is 1 to many relation. We cannot able to break the table into simpler form. Then we have to keep it as such. Then R1, E2. Because R1 having 1 to many relation, we can able to merge the relation into an entity. So we are making 2 tables into one table. That is R1 and E2. So R2 having the many to many relation, we cannot able to merge the things. We are keeping as separately. So the answer B is the right one. Then we are moving to the next question. So question number 2. Give the basic ER and relation models. Which of the following is incorrect? Okay. So now they are asking which statement is incorrect. So an attribute in an entity can have more than one value. It means what? Do you have any idea about it? So already we are gone through in this ER models itself. It means more than one value. If an entity, if an attribute have more than one value, we are used to call it as multi-valued attribute. What it is? Multi-valued attribute. It means which has been denoted with the double symbol. I gave an example for mobile number. Okay, may have 1 or 2 numbers. Okay, this one is correct. The next, an attribute of an entity can have more than composite values. What it means the person may have the address, right? Everybody having They don't address. So this is an attribute. How can I say this is an attribute? Everything has been declared as an oval ellipse symbol. We used to call it as attribute. So address, how we are declaring? First we have to define block number or door number, street, city, pin code. Likewise, the address field may contain. Okay, so one attributes may has been described and defined by the many attributes. We used to call it as composite values, right? So this one is also your right one. In a row of relation table, so what it relation table may contains like this. Relation table in the form of rows and columns. I hope you understand what I'm saying. Okay. In a row relation table, an attribute can have more than one value. This is not actually. If the student S1 may have the student ID, may not have more than one ID. The next, in a row of relation table, an attribute one value or null value. These two was done. So in this question, these two are the correct statement. I think hope you all understand about this ER model mapping into relation model. So far we are moving into the end of the sessions. Thank you and continue for watching.